So the fourth section of Unit A is about an introduction to real numbers. And I think outside of the math world, that sounds like a bit of a strange title. So in the math world, there are real numbers, and those are pretty much all the numbers you can imagine. And then we also have a classification called imaginary numbers. So imaginary numbers are a math convention that exists so we can handle some things that are kind of impossible to do. So we don't cover that at all in this course, but real numbers are basically numbers that exist. So anything on a number line in both the positive and the negative direction. We're going to take a subset of real numbers called integers in this little bit. And really what we're talking about with integers are just the whole numbers. Their negatives and including zero. So this number line is a good graphic to illustrate all the real numbers up to positive infinity and negative infinity, right? So integers, as I say, a subset of natural numbers or whole numbers, they're negatives and zero. So which one of these are integers? Well, 145 is an integer, negative 28 is an integer, 0.35 is a real number, but it is not an integer because it's not a whole number, right? Just in this trivia or lingo of math. And then the last one here, negative 2/3, it's a fraction. It's a real number, but it is not an integer. Integers, what we're talking about, are whole numbers. And so anytime these things kind of come up, I'll make a point of mentioning them because I think the lingo of math is something that even if you've done lots of math, you might have not noticed some of that language surrounding math. So intro to real numbers, numbers on a number line, numbers that make sense in your mind. We're going to go through the operations of adding, subtracting, multiplying, and dividing real numbers. And a lot of these are things that you've done before. We're going to talk through kind of conceptually. We'll talk about how you can use your calculator. And honestly, anytime you have to deal with numbers, putting money or dollars as a concept to that math can really help make some sense of it. So real numbers are positive and negative signs with integers. So let's use them. So say you borrow $10 from someone. We call it a debt of $10 or negative 10, right? Now, if I pay that person back, we could write it out as a mathematical expression as negative 10 plus 5. Well, I'd still owe them $5. I'd still be at negative 5 if I were to put a number on that. So then I bum another $10 off them and say, hey, I need some more lunch. So I was starting at negative 5. I'm going to add another negative 10, so negative 15. If somebody was owing you this money, if I was owing you this money, the math wouldn't be hard to do, right? So I now owe $15. So say I pay you back $20, right? And then borrow another 8. I could write that as a mathematical expression here, right? So negative 15 plus 20 would be up 5 minus another 8. I'd be ending up owing you negative 3 or $3. So that number line thing, sometimes I imagine that in my head kind of bouncing around on the number line. That conceptual understanding can be useful. You also have a calculator that has a button that looks like this on it. That button turns numbers positive or negative, right? Whatever they are, it'll make them the opposite. It is different than your addition sign and your negative and your subtraction sign, right? Sometimes they can be used interchangeably. We'll talk about how you can rewrite expressions with those, but I do think that this is a valuable key to use your calculator and these adding and subtracting or multiplying, dividing real numbers. So a lot of these, like I have done in the past, we start with simple examples. So if I have two numbers I'm adding together and they have the same sign, I would just add them together and keep that sign. 4 and 3 is 7. Positive 4 and positive 3 is positive 7, right? We know that. Now, if they have the same signs, what we do is add them together and they keep that sign. So these two examples are illustrating that. Over here, we have the same signs. You add them and you keep the sign. Here, adding the same signs, you add them and you keep that sign. You can enter these on your calculator, so try on your calculator. I tend to have a mind that can kind of just like kind of think about, but you don't have to just get it. You do have a really valuable tool to just double check your thinking as you go. So we've been doing adding numbers with the same sign, right? Now we're going to do adding numbers with a different sign. So you can totally use your calculator for these, but there is a way to do this in a different approach. So I can see that I'm adding two numbers. This one's positive and this one's negative. The rule here says subtract the two numbers, and whatever number is bigger, that sign is going to be on the answer. So I can see that I have a 3 and a 6. They have different signs, so I take the difference of them. And the one that wins is going to be the -6, right? It's bigger than the 3. 6 is bigger than 3, has a negative sign, so that's the sign on my answer. Let's try that again. So we have 4 and 8. We have a positive and a negative. Take the difference of them, and the bigger one wins. 8's bigger than 4, has a negative, so my answer has a negative on it. I'm going to avoid the fractions down here. This one, we have adding two numbers that have different signs. This is a -7 and a +3, right? I take the difference, and the bigger sign is going to win. These ones are a little more awkward only because they're fractions. So these are fractions that have common denominators already, right? So they'd have the common denominator. This negative could be thought to go with the numerator. So put negative sign with numerator. It could go with the denominator, it could go out front, but it just can't go in both places, which we'll talk about in the coming pages. So what this is telling me, we have -13 plus 7. So I'm adding two things with opposite signs. You could just do this on your calculator. I take the difference and go with 6, and negative's going to win. It's still over 2, right? That's the adding fractions I reviewed briefly in the video in A1. I would also have to reduce this. Oops, sorry, divided by 2, I get -3/1 or just a -3 as an answer. Give this fraction one a try. It might be worth breaking it up into steps. You can do that numerator math in your calculator, or you can follow these rules here. You subtract the numbers and take the sign of the larger. And then with fractions, we always have to simplify. In this case, I'd get an answer of 5/1 or +5. If a number is a negative, then you write the negative. If there is nothing, it's assumed that's a positive in front of it. And that's something you probably knew, but it's important that I say those things. With these ones, calculators are the easiest way to go. So if you haven't been using your calculator, it's probably good to pull it out for this one. Remember that that positive negative button is different than the subtraction button, and see if that one works. If you have any trouble with your calculator, just let me know. I'm happy to help you out. So if you are using your calculator, the second page isn't really that big a deal. If you aren't using your calculator, if you're trying to think through these conceptually, then it's important to kind of take a look at how these go. So go ahead with your calculator, think through them conceptually. Either way, I won't talk it all through. I'll just throw the answers up, because however it is you're getting there, that is the name of the game. Totally happy to have things work for you, however that is. So that was all adding. We're going to just do a little bit more on subtracting. So subtracting can be rewritten as an addition question. Honestly, for this one, that overcomplicates it. And all of these you could just put into your calculator, right? So there is a bit of a duplication here. And if you're not into rewriting it, that's absolutely fine. That one, no need to complicate it. This one, it would be 5 plus a -13, so I could take the difference and then the sign of the larger. Or if you're tuning me out because you're like, forget it, Marianne. I have a calculator that works. Just go for it. Totally happy with that. Good old fractions. So this is adding and subtracting with common denominators already. This is -5 plus a -7. If you want to rewrite it as an addition, the way this is suggesting. If not, you can just put that in your calculator as -5 minus 7. You're going to end up with -12 over 6. And we could reduce that to a -2 or -2 over 1. Last one, probably a calculator. Just make sure it works and you're reading your display properly, -2.2. So as much as I don't think that this is a super valuable shortcut or model, some people like it, probably using your calculator. This one can be really, really useful. So if you see two negatives smack up beside each other, that is understood to be a positive. It's like a negative times a negative is a positive. That's really what the next section is all about. I had somebody say, yeah, you can just turn that into a really big positive sign. So when you see two negatives right up beside each other, it means addition. So that makes these a lot easier to conceptualize. You might need a calculator for these, but work your way through with that. And just as an example, really showing how you can overcomplicate things, you could rewrite 1 minus -2 as just 1 plus 2. And of course, you're going to be able to evaluate that a whole lot quicker. And so that's just a bit of a reminder that, you know, sometimes the tips from textbooks or that kind of thing are not necessary for you, and sometimes they're really useful. And I do think a negative is really useful to think of just as a positive. Rewrite that one because it makes things a lot easier. Easier to put in your calculator too. So multiplying and dividing real numbers, again, something I'm sure we've all done. Let's start with ones and zeros. So ones and zeros are the biggest pains, it seems, in math. They're not difficult, but they're tricky. So anything times 1 is itself, right? We talked about that with writing equivalent fractions. Anything divided by 1 is itself. We talked about that as 5 written as a fraction, right? So these are all things that we've already kind of reviewed. The next bit about multiplying, dividing real numbers is addressing zeros. So zeros are a little bit weird. So anything times 0 is automatically 0. Doing your 0 times tables is easy. There's only one answer for them. Now this gets a little bit trickier when you're dividing. So 0 divided by a number, I'm just writing n as any number. That's, if I were to read it top to bottom, it says it's on. Put 0 divided by 5 in your calculator and see what it says. It should say that it is 0 as an answer. Now, conversely, let's put in a number divided by 0. So a number divided by 0. Again, if I read that top to bottom, that tells me no. Grab your calculator, put in 5 divided by 0. Your calculator is going to say error. That's a fancy way, or well, that's the way your calculator actually gives you the answer. This is, in mathematics, undefined. It's actually impossible to have a number divided by 0. And if you're bored and want something to do, ask Siri on your phone what 0 divided by 0 is. If the programming is still the same, they talk about a cookie monster and weird things. So ask Siri if you want to really waste some time. 0 divided by 0. It's kind of fun. Okay, so moving away from ones and zeros, I like those memory devices of the on and the no. It's amazing how much I actually have to recall that. The next little bit is about multiplying and dividing. So if the numbers have different signs, the answer is going to be negative. If the numbers have the same signs, the answer is going to be positive. So a positive and a positive makes a positive, and a negative makes a positive answer. And again, a lot of this stuff is stuff that you're going to remember, And also, if you're putting numbers into your calculator, remember that positive minus button, and then you can simply put these into your calculator. Moving across the top, remembering the zeros are key. And we had to do it rolling in the fractions. Like I said before, the negative is going to go with the numerator. That's why I find it easier to think about. So multiplying across the top and multiplying across the bottom. This is an example of them being smack up beside each other. So we get negative 6 over 15. I'd want to reduce that and get negative 2 over 5 as an answer there. Next one, remembering that a whole number is over 1. And in this, I'd have the negative with the 2. I like to think of it that way. So you have negative 9 times a negative 2, right, on the top, the numerators. That gives me a positive 18. And then a 1 times a 3 gives me a 3 in the denominator. Divide them both by, 3. And I get 6 over 1, or 6. There's a few fraction ones in here, so take your time with them. This tip of putting the negative sign with the numerator, I find to be really, really useful. I'll write the work for the later ones here, and you can give them a shot. Tried to put some tricky ones in there. Ones and zeros are always tricky. And remember that it's not error, it's undefined. So give those ones a shot. I made a mistake in my key already, I just noticed. This one says no, and I wrote 0 in my key. I'll have to fix that. And this one says on, and I wrote undefined. So in my key, I got them backwards. In this video, they are correct. So now that we've sort of gone through all of these integers and signs, we're going to cycle back to order of operations. So there's a lot going on with these. I find that sometimes people are like right on board with it, and sometimes it just takes a minute to see the meaning behind the numbers and the brackets and the negative signs. So be patient. It doesn't always come instantly to us all here. So with these ones, we're going to stay with these grouping signs, remembering that that big dividing line was a grouping sign. So I do it was on the top first, and then finish up. They're both divisible by 3. My answer is going to be 14 on this one. Other ones have more going on. So again, kind of prioritizing top and then bottom, right? The grouping sign of that big dividing line. I'd have negative 4 plus negative 12 all over negative 6 and negative 2. You can do more than one thing at a time, but I'm going to try and keep it slow. On the top, I get negative 16, and on the bottom, I get negative 8. Simplifying this a bit, it's a negative divided by a negative. I know my answer is going to be positive, right? 16 divided by 8 is 2, or I could divide the top by 8 and the bottom by 8 to simplify my fraction. Either which way. Do watch your calculator. It does take a little bit of extra effort. Your calculator can steer you wrong if you're not putting the brackets in. So I think I mentioned it before, these intermediate steps, you can totally use your calculator as a tool, but I use the calculator as a tool and still write out the equivalent expressions doing one step at a time. And I find that I just make fewer mistakes. So next one here, I'm going to prioritize, and I'm just going to switch colors to show you. I'm going to prioritize this multiplication and this multiplication, then the subtraction in between. So I'd have negative 2 and negative 4 is an 8 minus a 30 on the top. And the bottom, you can do it now or you can do it later. I'm going to go negative 44. On the top now, I'd have 8 minus 30 is negative 22 all over negative 44. I'd simplify that. I have a negative divided by a negative, or I divide them both by 11. And I'd get an answer of, whoops, I could have divided them both by, okay, I'll get it, 2 over 4, and I could go further on that one, which I didn't see coming, to a positive 1/2. Last one, talking them through. Put me on mute, fast forward it, whatever you like if you don't need it. I'm going to do the 4 times the -6 first, remembering that this is my grouping sign. I'm going to prioritize the top. I have -24 minus 2 all over -4. On the top, I'd have -26. On the bottom is -4. Reducing this, they're both divisible by 2. So I get 13 over 2 as a final answer, and that is a positive 13 over 2. Zeros, ones, and negative signs are the most common places that we make mistakes in math. And it's not because they're hard, they're just easy, simple mistakes to make. So be kind to yourself and do what you can to slow things down. So you can do these with your calculator. You do have to use brackets carefully. If you feel like using your calculator, you absolutely can. I'm going to stay with the approach that we've been doing so far, right? You might, on your calculator, have to do the brackets in there to show that grouping to your calculator. I think, for the most part, it's usually easier to just do them kind of straight out. So this one, we'd have -5 on the top, and we'd have, what's that, 10 on the bottom, or a -1/2. Last ones, positives, negatives, order of operations. We're going to do what's in the brackets first. So I'd have 7 times 3, or 21. This one, I'll go down first. I'd have 56 minus 40, or 16. These ones over here are particularly tricky, so brackets absolutely matter. This is a bit of a throwback to the exponent notation that we did, right? So this is saying -5 times -5. Well, that would be a positive 25, because if two things have the same sign, the answer is positive. It's still -3, so my answer is a positive 22. This one looks very similar, but it's different in that the squared is only on that 5. The negative is out in front, so basically it could be considered like that, which is totally different in its meaning. That's meaning 5 times 5 and the negative of it. So that little bit is -25. I'm going to rewrite that as +3 because this is hurting my head. And I get a final answer on this one of -22. We'll revisit those ones. They're definitely on the tricky sides, and the bracket locations absolutely matter. And so we'll keep going with those ones as we see more in our algebra work in this chapter A, or this unit A. So the last little bit is something you might remember, but it might be a little different. In all of these, we could have used BEDMAS, or we could use the distributive property. So the distributive property means that if this 7 is multiplied by these two things, we could kind of pass it around and do it one at a time. Oftentimes, I do think people remember distributive property. So I do it one thing at a time. So -7 times 1 gives me a -7. Then I do that -7 times the next thing in the bracket. So -7 times a +6 gives me a -42. And then I can do the math on that. So it gives me a final answer of -49. So this pattern and the arrows, I do it to slow myself down. Watch the signs. -3 times 5 is a -15. Then that 3 is going to go to the other. -3 times 6 is a -18. And so I would get a -33. Oftentimes in class, I'll have us do it with order of operations and the distributive property to just double check that it actually makes sense. In this one, if I did it that way, it'd be -3 times 11. They're equivalent, right? It doesn't matter which way you do it, whether it's order of operations, or distributive property. Distributive property comes in as we move into algebra because sometimes you can't simplify what's in the bracket. So let's keep practicing this pattern. Negative 2 times 2 is negative 4. Negative 2 times negative 3 is a positive 6. So my answer is a 2. Over here, a bit of a teaser for where we're going in the next section. We have negative 2 times a. I can't actually multiply them, but when things are right up beside each other, that implies multiplication. Negative 2 times a positive 4 is a negative 8. And as I'll elaborate on in the coming sections, we can't actually add those. That's like adding, 2 apples and 8 bowls or something and saying, how much do you have? Well, you have 2 different things, and you can't actually give a total for that one. These ones are a bit tricky. So in the last couple pages, we talked about having 2 negatives right up beside each other. A negative of a negative makes a positive, right? So here we have negative 3 times a 1, basically, or a negative of a negative is a positive. And then one more would bring me back to a negative. A lot to keep track of. You could think of these ones as being ones, if that helps. Here we have a negative in front of a negative, and 2 negatives, as we talked about before, is a positive. And so I like putting the signs with the numerator because that's kind of a fail-safe for me when I'm dealing with fractions and signs. So that gives us a little bit of an introduction to real numbers.